Hi, so for today we are going to talk about intervention for calculus drafting, and this will be rational expressions part 2. And for today's video, we are going to solve some rational expressions. So many problems involving reduction to lowest term, addition and multiplication, and at the same time subtraction. And at the same time, we're going to talk about division also of rational expression and complex fraction. So if you are aiming to master rational expressions, so please keep on watching. So okay, so for the first one, we have to reduce the fraction to lowest term. We have 15x squared all over 12xy. So the key in reducing fractions into lowest term or rational expression is to, of course, so simplify first. So you have 3 times 3 times 5 for the 15. So you have 3 times 5 for the 15, and you have x times x. So you can dissect 15x squared by just factoring all of the multiples of the numerator. Same thing with the denominator. You have 3 times 4, which is 12. Then you have x times y. So in that case, we can see that we can cancel 3. We can cancel out 3. We can cancel out x. Okay, and we are left with, we have 5x all over 4y. So that's just how simple it is to reduce the fraction or the rational expression into its lowest term. Okay, so for letter number 2, we have 4x squared y all over, we have 18x y cubed. Okay, so we have 2 times 2, that is 4. Then we have x squared, so that's why we have x times x. And then we have y all over, we have 2 times 9. Okay, that is the, they are both divisible by 2. So we have to isolate 2 and multiply it by 9. So you have x, y times y times y because of the y cube. So what's gonna happen here is this 2's will cancel. 2 all over 2 will be 1. And this 1x will cancel. And you have also 1y will cancel. So whatever it is that is remaining, that's your answer. So you have 2x all over. We have 9y times y, that is y squared. Okay? That is for the reducing the rational expressions, okay, into its lowest form. So for number 3, we have 14a cubed b cubed c squared all over, we have negative 7a squared b raised to 4c squared. Okay, so they're both divisible by 7. So I can have 7 times 2. I have a times a times a. I have b times b times b, c times c. So you have negative 7, and then you have a times a, and you have b times b times b times b because of b raised to 4, and then 2c. So as you can see, this will cancel. 7 divided by negative 7, only you have a negative because it's divided by negative. So the a's will cancel. You have a here, you have a here. So and then of course you have b here, and then b cancelled here. Of course, for the cc, you have cancelled cc. So what remains is negative 2, and then you have a all over, the 1b is b. Okay, so that's how you reduce the fraction to lowest term. Okay, so we just dissect, of course, the factors that involves the numerator and the denominator. For number 4, we have x cubed y minus y cubed of x. Okay, and then we have x squared of y minus xy squared. So in this case, sometimes it involves the simplification of rational expressions involve factoring. So as you can see in the numerator, let us first focus on the numerator, that we can factor out x and we can factor out y because it's both common to the numerator. So if I can factor it out, x to y, so I'm left here with x squared. Why? Because x times x squared will be x cubed. Okay? And I factored out y, so simply I'm not going to write anything because I simply factored out y. Minus, okay, I have xy, I factor 1y, so what's the remaining here? That should be y squared. And I factor 1x, so x here, so there's nothing to write here. So that if I'm going to distribute this will result to what? This also. Okay? So I simply factor it out using the greatest common factor. So on the numerator or on the denominator, I can factor y and I can factor x. So you have x, y also, and then you have x, okay, minus, I factor out 1y, and we have x minus y here. Okay? So as you can see here, this will cancel. xy and xy will cancel. And you are left with x squared minus y squared all over x minus y. But take note that x squared minus y squared is still what? Is still a special product. So we can just factor it out still by x plus y and then x minus y all over the x minus y. So as you can see, this would be cancelled. Recalling your difference formula, you have a plus b and then you have a minus b. That's what we did here. Okay? So that's why you have a factor that is x plus y. Okay, that is your reduced factor. All right? So into lowest term. So for number 5, we have x squared minus 4xy plus 3y squared. Okay? All over, you have a y squared minus x squared. So obviously, okay, we can factor out the numerator by simply this. We have x minus 3y and then we have x minus y. So this can involve trial and error if you're going to have a special product. Okay? So means that what two numbers that if we multiply, okay, it will be 3y squared. So that is negative 3y and negative y. That's negative 3y squared positive. And that if we add, okay, that is negative 4xy. Okay? So usually that's the criteria. Okay? And if we try to add, okay, or try to foil. Okay, let's try to foil. If we try to foil this, you have first, that's x squared. You have outer, that's negative xy. You have inner, that's negative 3xy. You have last, negative 3y times negative y would be 3y squared. So if you try to simplify this would be x squared. Negative xy minus 3xy would be negative 4xy plus 3y squared. So hence, this is the factor for what we are looking for the numerator. So let me just erase it. And then on the denominator, it's obviously we're going to use the same formula here. So you have y plus x and then we have y minus x. Okay? So at the first place, seemingly there is no cancellation that will happen because x minus y all over y minus x is not the same. But if we just try to factor out the negative here, so you have y plus x, then factored out the negative here. Okay? I'm going to factor out some negative. Let me write this first. Okay? Factor out the negative here. Negative 1. This will become x minus y. And then you have y plus x. Okay, so it means I factored out the negative 1 on the y minus x. So it becomes x minus y. So as you can see, the x minus y now will cancel. So now you have negative of x minus 3y all over you have y plus x. So it's the same thing if you write this answer as negative of the x minus 3y all over y plus x. It's still the same because negative or positive divided by negative will still be negative. So that will be your answer for this, right? Or you can distribute the negative. So you'll be having negative x plus 3y all over y plus x. Or rewriting, you have 3y minus x all over y plus x. So this could be also the answer. So for as long as they're already factored out and they're already simplified, then we will not be having much trouble in the answer. Okay? So for number 6, we have 6x squared minus 3xy all over negative 4x squared y plus 2xy squared. So we can factor out here commonly in the numerator as x, and of course the 3 because the constants are divisible by 3. So I can factor out 3x. So that's why I have 2x. So 3x times 2x is 6x squared minus y. Okay, because if I multiply 3x and negative y, that will be negative 3xy. Okay, I can also factor out 2. Okay, I can factor out 2, can factor out x, and I can factor out y here as the greatest common factor. So you have 2x to y. Then now you have, since this is negative, so you have negative 2x. So negative 2x times 2xy is negative 4x squared y. And then plus k y. Because 2x twice squared if I'm going to multiply this. Okay? So that is our factor here. Alright. So upon doing this, okay, we shall be having what? Okay. So you have 3x, 2x minus y. I can factor out again the negative sign. So if I factor out the negative sign, this becomes 2x minus y. Here, I can factor out the negative. So that you have 2xy here. So as you can see, 2x minus y will now cancel. You can always factor out the negative 1 sign. Okay? So you have already 3x all over negative of 2xy. Or simply, you can still factor it out. Or you can still cancel. What? You can still cancel x. Okay? So that your answer will now be negative 3 all over 2y. Okay? That will be your final answer in the reduction of our lowest term. Okay? For number 7, you have r cube of s, r cube s plus 3r squared s plus 9rs all over, you have r cube minus 27. So for this case, on the numerator side, we can factor out r. Okay? We can factor out r and s because it's common. We have r, s, we have r, s, we have rs. So I can factor out rs. So if I factor out rs, that would be r squared plus I have 3r, okay, plus in the last term, I factor out rs, so I have 9 here. And on the denominator side, we know that this is the cube formula. Difference of a cube. So I can factor it out as r minus, okay, r squared or r cube minus 3 cube. So you have r minus 3, okay? Using the formula of the cube, difference of a cube, you know that it will be a minus b, okay? At the same time, that would be a squared plus AB plus B squared. Okay? So your A here would be R, and your B here would be what? Of course, 3 cube, R cube, and then we have 3 cube here. So this will be your A, this will be your B, the 3. Okay, so that's why we have A minus B here. So you have A squared, you have R squared, okay, and then you have AB, okay. Okay, you now have AB, that's 3R, and then you have B squared, that is 9. Okay, so that you will be able to cancel this, and you are left with the RS all over R minus 3. And you cannot cancel R because of the minus sign here. You can only cancel if it is in terms of multiplication. Alright? So, that's enough for reduction. How about for the multiplication? Okay? So, how about for the multiplication of rational expressions? Okay, so let's try to have number 8. Okay? So for multiplication of rational expression, we just simply have to understand one rule here. Okay? Before we even multiply by numerator times numerator and denominator times denominator, we can first what? Simplify. Okay? So we can simplify. So if we do that, for example, 2x all over 3y squared times x 6y all over x squared. Okay? Here, we can just simplify x divided by 1x here. And you have y divided by 1y here. And then you have 6 divided by 3. So this will become 2 divided by 3, which is 1. Okay? So now, you can now proceed with multiplication such that you have 2 times 2, that would be 4 all over, we have y and x. Or simply, you have 4 all over x to y here. Okay? So, or you can just simply multiply it if the first, you can multiply it if there are no factorials, or there's no factoring involved in the expression. Okay, you can directly multiply numerator by numerator and denominator by denominator and then simplify, reduce to lowest term. But most of the time when we are trying to multiply rational expressions, it involves factoring. So for example, this example, so now you have 9 all over x plus 3 multiplied by x squared minus 1 all over you have 6. Okay. So, let's try it first to factor. So, you have 9 all over x plus 3. There's no factor in it. But x squared minus 1 is x plus 1 and x minus 1. Again, the difference all over 6. Okay? So, if there is no factorables, oops, I'm sorry. This should be, the numerator should be 3x plus 3. I'm sorry. So this should be 3x plus 3. Okay? So I can factor out also the denominator for 9. We have 3, then x plus 1. Greatest common factor is 3. Multiplied by x plus 1, and then x minus 1 all over 6. So if I do that, the x plus 1 will cancel. And you have 9 all over 3, that will become 3. Okay? So 3 all over 1, because 9 divided by 3 is 3 all over 1. So you now have, what? 3 times x minus 1 all over 6. Of which, still, you can factor it, or you can still reduce this into 3 divided by 6. So 3 all over 6 would be 1 all over 2. Okay, or 1/2, simply 1/2. So you have x minus 1 all over 2. So this will be your answer for multiplication of the rational expression for this problem. Okay, so for number 10, we have x squared minus 4 all over, you now have xy squared multiplied by 2xy all over, you have x squared minus 4x plus 4. Okay, first factor out. So you have x plus 2, then you have x minus 2 on the numerator here. Then you have xy squared, multiply it by 2xy, so nothing to factor here. And the factored form of the perfect square trinomial here would be x minus 2 and then x minus 2, or x minus 2 squared. So we can see, we can cancel some variables. So first we have x minus 2 and x minus 2 here. So you can also cancel 1x here and x here, and the y here with 1y here. Okay, so now if you're going to simplify it, you have 2 times x plus 2, the 2 here and the x plus 2 here, all over, okay, you have y here remaining, and then you have yx minus 2 here. Okay, and this will be your answer since there is no, or there's nothing to be reduced in this given form. Okay, so how about for number 11? Okay, let's try. You have 6x minus 12 all over, you have 4xy, 4x plus 4x multiplied by y squared minus 1 all over, you have 2 minus 3x plus x squared. Okay, so 2 minus 3x plus x squared. So for 6x minus 12, we can factor out 6. So you now have x minus 2 all over. For this one, I can factor out 4 and then at the same time x. So I can factor out 4x, then you have y plus 1 in here. So that if I'm going to distribute 4x, that would be 4xy, and then distribute 4x with 1, that would be 4x. Okay? So, and then we're going to multiply it by y squared minus 1. Factored it out. That's, again, the difference of two squares. So this becomes y plus 1 and y minus 1 again. Okay? All over, as you can see here, x squared, we have 2 minus 3x plus x squared. Okay? It's just simply, okay, the x squared is on the last part. Okay? But if you're going to really think of it, x squared minus 3x plus 2, that's the thing if you rewrite it. Okay? So now you're going to factor, okay, this given. So if you factor this, we have x minus 1, and then you have x minus 2. But since it is written as the reverse, okay, here, so we can clearly say that we can write 2 minus x and 2 minus 1 minus x here. Or 2 minus x and then 1 minus x. So again, since this is inverted, okay, here, so we can rewrite here as the roots as we have 1 minus x and then 2 minus x. So if I'm going to do that, you'll have 1 minus x, then you have 2 minus x here. Okay, do you have something to cancel? Yeah, surely we have y plus 1 and y plus 1 will surely be cancelled. Okay, so right now, if I'm going to, again, rewrite this, so you have 6, okay, and then you have x minus 2 all over 4x multiplied by y minus 1 all over 1 minus x and 2 minus x. Now, if I'm going to, again, get the negative, okay, get the negative or factor out the negative here in 2 minus x, that would become negative, and then x minus 2, and then you have 1 minus x. Okay? So I just factored out the negative in x 2 minus x, so that the negative 1, so that if I'm going to distribute, that would be negative x, and negative times negative, that would be positive 2. Alright, so I hope that's clear. So now we can cancel again x minus 2 and x minus 2 in here. Okay, so that we now have 6 all over 4x multiplied by y minus 1 all over negative of 1 minus x. Alright, so that's how it should be. Okay, so, and right now, I can factor or I can cancel 6 all over 4 into lowest form. 6 all over 4 would be 3 all over 2. So that's why I have now 3 all over 2x multiplied by y minus 1 and then multiplied by the negative of the 1 minus x. So simply that's become 3y minus 1, and then you have negative 2x of 1 minus x. And if I simply just distribute again the negative here, okay, the negative here, this will become what? This will become 3y minus 1. Distribute the negative, that will be 2x. This will become x minus 1. Okay? And that is our final answer for this. Okay, for this problem. Okay, that is for number 11. Okay? It's for number 11. Okay. And I think I'm going to stop here. Okay? Because the video's too long, so I'll be creating another part 3 for the division, addition, and subtraction, and as well as the complex numbers, okay, or complex fractions. So I hope you learned something from this video, and if you learned something from this video, please don't forget to subscribe to my channel for more videos about mathematics, especially if you're in engineering. Okay, and of course, we are going to talk about the whole intervention for calculus drafting. We're going to finish it, okay, this year, uploading videos. So thank you so much, guys, and I hope you learned something from this video, and God bless.